Welcome to ScalaUA conference.
My name is Nemish, and I'm the author of Creo macro serialization for Scala. Who uses cryo serialization in your programs? Not that much. Okay, I used to work for Evolution Gaming, and we were doing all those gambling stuff. We used event sourcing as a architecture for kind of, our server-side approach, which you probably heard in a talk before, right? And we use cryo for serialization in our cluster. And when you use event sourcing, you have to manage lots of events, and you have to handle serialization very carefully. And most of the time, you should be aware of changes over your domain. So you have to be very careful with your serialization. So most of the serializers were written by hand. So it was a lot of code. I love metaprogramming very much. So one of the ideas was to actually simplify these things by metaprogramming and generate those serializers with macros, which I did. So if you take a look at Cryo GitHub page, you can see that there are Cryo macros. Evolution Gaming open sourced that project, so everyone can use it freely. So I'm gonna show you what can you do with those macros. Those are extremely simple. All the APIs here is 6 functions, 3 macros. Basically, those work only with case classes. So they are designed especially for case classes, so I didn't care about anything else. You can see the code generated by enabling this ScalaUA option. So if you like to have it written somewhere in files, or just take a look what's the boilerplate being generated, you can easily do this. And it's that simple to create a serializer. You just call a make function and pass a type of a case class which serializer you want to get. It supports basic primitive types of Java. It supports more complex types like big decimal, datetime, Yoda datetime, or Java time instant, even final duration. If you work with Akka, it's useful. It supports value classes, options, either, and Scala enums out of the box. Also, definitely it works with collections, maps, only mutable maps currently, because obviously you should use immutable maps. It respects some of the annotation, so if you use Scala transient annotation, this won't be serialized. And if you use this empty annotation, your option strings can be serialized to an empty string in case of a none. It's sometimes useful. Who of you have ever written a macro? Okay, so if you take a naive approach and try to check types in your macros, they won't work with type aliases out of the box. You have to manually call the alias or whatever. And so in Creo serializers macros, you can use type aliases. It works out of the box too. So when manually constructing macroses for inner objects, you either have to write those manually, or you have to register those in a special Cryo register for it to know that this class is serializable. Or you can do it with implicit serializers. So if you define an implicit serializer, it will be automatically used by macros. So if you see there is an outer case class that contains inner A and inner B classes, and we can define an implicit serializer for inner A, or we can even manually write an implementation of serializer for inner B, and just call a serializer macros for generation of outer serializer, and the macros gonna use those, find and use those serializers. It's very, very helpful. Also, it's always very useful features to create serializers for enumerations. We use it all the time in evolution. So let's take a look at complex example. Yeah. So let's serialize a command that contains a game, that contains a game type, and one of the commands is an action that contains a enumeration. We define several implicit serializers, mappings. And then we want to serialize this bunch of case classes that kind of create this algebraic data type. Who uses these kind of structures? Okay, so you know what I'm talking about. So it's that easy. We create a constant serializer for our case object. Use inner serializers for creating enumerations. And those implicits going to be used automatically to serialize game type inside game, inside start command. So that's it. As a result, you're getting very concise code. All the boilerplate is generated. You don't have any reflection, runtime reflection, and you have full control over. The most important stuff is that you have full control over IDs of your fields and your classes. This is very important in case when you have your application running for some time and you have changes in your domain model, you have those changes to be backward compatible. It's very important. So most of the time you either write your serializers manually to have a control, or you use macros, for example. So that's a very powerful technique, and it works in production for, I guess, more than a year. Yeah, just check it out. That's all I wanted to show with serializers. If you have any questions, please ask. Cool, no questions.
Is it hard to write different kind of structured serializers like message pack, for example, protocol, or JSON, specific JSON, something like this? I don't see currently any problems, but you mentioned macros. Don't understand why this.
Sorry, I didn't really get the actual question.
The actual question is a complexity of writing serializer according to protocol message pack and its deserialization of its types, for example. If you know this protocol, it's like JSON but binary or something.
Don't know. I have to look, but I guess
you have very few classes. Only big decimal, for example, is.
Well, that's good enough to serialize all the data in evolution gaming games. So, and if you need anything else, it's very easy to add support for this, because the whole implementation of this stuff is 200 lines, 280. It's simple as, I don't know. I can't write it any simpler. It's very simple and straightforward. So you can basically clone or copy paste this code and just write another line like this, and you have a support for your custom type. Even better, you can create a pull request, which is most likely going to be accepted. So I think it's fairly easy to do. Or I'm a consultant, you can hire me and I'll do this for money.
Thanks.
So I have another fairly quick talk, dreaming about the language. So I've been programming for more than a decade, and I've used different kinds of programming languages. Who ever used more than 10 languages in their lives? 5? Okay, 3? Okay. So I'm kind of seeing them all, and basically we can divide those into large groups, languages that are statically typed and dynamically typed. And everyone, I guess, used either one, right? Okay. So why we use statically typed languages? They are safe. You know that if you receive an integer or a string, you can't receive anything else. This guarantees is basically all that programming is about. Programming is about guarantees. We love guarantees. Statically typed languages tend to be fast, because this information about restrictions on types can be very efficiently used by compilers to generate efficient code. So if you take a look at my favorite n-body problem from computer language benchmarks, everyone, I guess, knows about this stuff, right? So if you take a look, solving this problem takes 8 seconds for a Fortran program. For, I don't know, Java, it takes 21 seconds. All of these languages are statically typed. Where the dynamic ones? Here those are 7 minutes, 12 minutes, 13 minutes. Not that fast. So I claim that maintainability of a statically typed language is higher. It's easier to maintain because you have those guarantees. That's always good. It's easy to refactor. It's supposed to have better tooling, because compiler knows the types. Your IDE probably should know types. So you can get things like, I don't know, you all know this, like, I don't know, auto serializer, you can write get after completion. Oops. You can have a dot completion and see all the methods with types. That's wonderful. There are things you can do for dynamic languages, but it's not that powerful. So this is good, right? But what you get, why people use dynamically typed languages? I claim that one of the main reasons is this fast development cycle. That when you start your program and start building your program, you not always know what you're doing. So you have to try different things. So if you have this instant change and get a result cycle, it's very, very important. Like in PHP, why everyone writes in PHP? Because it's like F5 or Command R, it's instant. It's very, very important. Dynamically typed languages are simpler. I claim that those are simpler because you don't care about types. That's inherited simplicity. You don't write type annotations. I hate writing type annotations because when I write programs, those types are here. I know those. I just don't care enough to write those. And the second most important thing in dynamically typed languages is that those allow you to have code with type errors, which is very bad when you have a large project and you have to maintain it. But when you develop a thing, sometimes you just don't care. You want it fast. You change a return type of a function, and you have 15 places where it's going to be broken. But you don't care. That code probably won't be ever called. That simplifies and speeds up development so much that Netflix choose JavaScript and Node.js for their development instead of Java. Because this development cycle is very, very fast. Startup time is very, very short. So, I don't know, for myself, the development cycle for me looks like this. Usually, when I came to a new domain area, I have no idea what to do. No idea. I just read documentation, Stack Overflow, copy paste from Stack Overflow into a new project, and hack and just get results as fast as possible. So these cycles continue until I finally see a solution, like a general solution that I can factor out and create a design and architecture out of this. But these prototyping cycles are a very important part. And I claim that this is one of the most important reasons why people tend to choose dynamically typed languages for prototyping. So that's the reason why Ruby or Python or JavaScript are often chosen to be the prototyping languages. You don't write types, you don't care, it's fast, development cycle is fast, and you mostly don't care about the real performance. You don't care if it's 10 seconds or 1 minute, sometimes. And in this diagram, test-driven development doesn't work because you change code so fast and so often that just tests are gonna be things that do not help but мешают. So can we have a best of two worlds? Because we have this strict evaluations and we have lazy evaluations. We can combine those in one language, for example, Scala, right? So we can write a lazy keyword or this call by name arrow, and we have a lazy evaluation, strict by default. Why can't we have like best of these two worlds in a single language. And I claim that the closest one is actually, who knows what that? Go, exactly. Why?
Go steal model from ML. So it's
That's fine. I'm gonna talk about that. So why? Rob Pike said, the designer of the language, said that the fast compilation time is very important. He's right. Go compiles very, very fast. And it has local type inference, so you don't have to write types for your internal vars, vals, all that stuff, which is very useful. So you don't write type annotations, have fast development cycles. Go is wonderful and that kind. But for statically typed languages, they kind of abandoned last 20 or 30 or 50 years of programming language I don't know, things that came up, people came up for like 50 years in type systems, etc. So it doesn't have, first of all, it doesn't have global type inference, so you have to write types for your functions and for your data types. It doesn't have parametric polymorphism. I mean, come on, that's just stupid. So all of your, it has functions as a first-class object, so we can pass a function on or you can return, but you can't generalize on its parameters, so it makes it almost useless. It's not expression-based. In 21st century, it's not expression-based. If is a statement in Go, it's just stupid, I guess. So another one is JavaScript. So it's dynamically typed, and people, I guess, tend to love it. I don't know why. But, you know, it's dynamically typed, and you end up either with TypeScript or ScalaJS. So you tend to, it's very good to have a language, dynamically typed language, to write a program. So it's fine. It's fine. The problem starts when you have written program and start to maintain it. It's like 500,000 lines of code. Then you're doomed. Then you need a type system. So we have Erlang, which is dynamically typed, and there is a project which infers types for Erlang projects. So you finally end up with a type system for your dynamically typed language. There is also Swift. Who knows about Swift? It's very nice language. Please take a look at it. But again, it doesn't have a global type inference, and it's quite complicated with a bunch of stuff. So I have a dream. So I dreamt about the ideal programming language that could possibly combine the benefits of both worlds and leave minuses of the worlds. So I see it as a strongly typed language with global type inference. So there are type systems that allow you global type inference. There is a restriction of system F type system called Hindley-Milner. Probably some of you have heard about it. There are languages based on this type system, actually Haskell, and different sorts of ML languages like OCaml and Standard ML. Also, if we have an ability to choose between strict and lazy evaluations, why can't we choose between static and dynamic modes for your language, for your compiler? So I think it's very important to have this. It should be expression-based, it should be functional. It's 21st century, you can't write C anymore. It should be relatively simple, because currently we have description of kind of Scala language, right? So we have static type and we have pretty good type inference. We can use dynamic things with trade dynamic, right? who ever used dynamic in Scala? There is dynamic in Scala, check it out. It's expression based, but it's not simple. I do trainings for people who want to learn Scala, and they overwhelmed all the time. Because I tend to say that Scala is like a superset of all language features combined. So if you know Scala, you know like everything. So you take away some part of Scala, and that's say C++ or JavaScript or whatever. Superset of all features. So it's very smartly combined, but it's just a lot. It should have unpolluted syntax, because what you can end up with is, for example, always seen Rust. It's a wonderful language, but you end up with these kind of things. I call those forced. Yolki. It should have polymorphism, algebraic data types, and pattern matching. I think that language without pattern matching in the 21st century is just weird. Like Go. Also, I claim that it must have garbage collector, because if you use functional programming techniques, they rely on a garbage collection very, very much, so it's quite important to have it. So I haven't found this language. I tried Haskell. Who tried Haskell? I have a weird experience with it. It has 25 years of legacy. There are very, very weird and wrong solutions there that can't be fixed anymore, because they are everywhere. Like 5 types of strings, being the default one, being the worst one. It's just lazily evaluated a single linked list of 4-byte characters. There is a new one. Who knows this logotype? Right, it's Idris. It's kind of Haskell done right. It's much better for me than Haskell. It has a dependent types. Who knows what dependent types are? And one of its authors, Edwin Brady, have a great talk. Check it out, called Type-Driven Development, which is very cool. He describes how he starts thinking about program in terms of types. He writes these types, and the compiler infers the implementation of functions for him, because apparently it can. It's very, very cool, but it absolutely contradicts my experience. I never start with types. I start with copy-pasting from Stack Overflow. And there is OCaml and SML. Whoever used OCaml or SML? Great languages, but each of those have so much done wrong that it can be used only combined. Apparently, you can't do this. So I can't say that I did it. It's on so early stages that I'm mostly embarrassed to show it to you, but apparently we had this empty slot for a talk. One of the guys couldn't make it, so I was asked to talk about something. So I have this very early implementation of language called, I called it Laska. Scala shifted to Laska, Laska Haskell, something like that. So it has kind of Scala syntax. It must have a global type inference. So you see there are no types written manually, but if you try to run it, it executes, it calculates the factorial, it type checks, because you see I gave it a mode, static mode, So it runs in static mode. It type checks. So if you try to, I don't know, n should be int here.
Where are red squiggles?
Huh?
What about red squiggles?
Sorry. It has a IDEA plugin already, starting from version 0001. But I'm sorry, not always works as expected. So if you try to run it, it says that there is a unification error. It can't unify int and boolean. But if you run it in a dynamic mode, it's gonna compile and start running, and it's gonna in runtime. So you see it prints length factorial of 8, but then it failed with a runtime type error. So I guess this is very important feature when it finally can be used. So you can have both worlds, best of both worlds. So you can manually put types just for documentation or just to ensure that the type inferencer won't infer something else. So you can use this, or you can kind of use a gradual typing. So you can some of the arguments you can give types, some of them not. It's called gradual typing. So I've implemented an embodied solution for this in Alaska, and it worked. It's large relatively, but anyway, it works, and it works for 14 minutes, close to Python, which works for 13 minutes. So it even calculates something. It was very fun. Also, there are some ideas I would like to talk. So maybe gradual typing for future. Maybe some linear types. Who knows what linear types are? Rust is based on it. It allows you to a compiler to track everything you use, every memory allocated, and it can guarantee by type safety that all the allocations, not allocations, but ownership of the memory is correct, so it doesn't require a garbage collector. So it's very, very smart idea. There is also idea of liquid types. Who knows what liquid types are? So basically, if you write kind of in a defensive way, you have this require or assert functions in the start of the function that checks that arguments of your function are in the correct, kind of have correct values, right? Who does this? Sometimes, okay. So it may look like this. So there is a project called Leon. It's, I guess it's a compilation plugin for Scala, right? Compiler plugin. So basically, you can say ensuring result equals or greater than 0 of the size function of a list. And it's going to be checked in runtime, but it also can be checked in compile time. So if for an empty list I return, say, -1, it's going to compile it and say that size function is wrong. In case of empty list, it returns a value that is not greater or equals than 0. So you can have these kind of checks or proofs, if you like, in compile time. This is a very powerful technique. And you don't have to manually annotate anything else. Just write this assertion. Also, I'm thinking about adding metaprogramming facilities. I'm going to read the paper of Zhenya Burmaka about metaprogramming in Scala, because I'm impressed with it very much. That's why I use macros in Scala. Also, it's last case based on LLVM, so it's possible to generate very efficient code like vectorization using MMX or SSE instructions, or even generating code for running on GPU, like CUDA, and other machine learning tasks. So it's on a very, very early stages, but if you're interested, check it out. Thank you. Questions if you have any.
When you list like different languages, why you not mention like Groovy? It's almost like cover all you want.
Well, it's JVM based.
Yeah.
I forgot to tell you that I don't want a JVM based language.
Okay.
A couple of reasons, because you really have to do weird stuff to do functional programming in the JVM. Because you can ask compiler authors, it's just very weird. One of the reasons is, well, only starting from Java 8, they have functions as an objects, lambdas. And they don't have tail call optimization. You can't do anything useful without tail call optimization in the functional world. So LLVM has it out of the box. It's there. And one of the things is that JVM started in times where we had lots of architectures. It was very expensive to have different backends. So it was easier to write one virtual machine and run everything on it. But LLVM kind of sort this, and we have reduced the number of architectures a lot. So we have like 3 main currently that covers like 95%. So I don't see any point in Java these days, other than lots of libraries. I guess this is one of the reasons Scala is going native. Okay, thank you.